Good morning, students.
Sir.
Thank you. Sir. Started? Hello. Hello. Started? Good morning, students. Let me continue atomic structure. So in last class we had discussion on de Broglie equation and Heisenberg uncertainty principle. Right, according to de Broglie, so nature of any object whenever it is in the motion will be dual nature. Same way, when dual nature is there, definitely finding position and speed at a time it is very difficult, so impossible. It is impossible to determine position and velocity or momentum of any object whenever it is in the motion. Electron like particle, it is very difficult. Why? Because electrons are very small microscopic particles. So for microscopic particles it is very impossible to determine speed and position. Okay, even though if you calculate, then definitely there will be error in at least in one term. Okay, either velocity or position. This is what we had in last class discussion. Right, today let me continue Schrodinger's wave equation. The Schrodinger wave equation, Schrodinger is the scientist name. So he explained wave mechanical model of atom. Wave mechanical model of atom. Actually it is very difficult. Wave mechanical model of atom. Model of atom means actually here with respect to what a wave mechanical model of atom means what here he consider one electron, means for only one electron system only he gave one equation for only one electron, he gave this model only for one electron. So according to Schrodinger, so free energy means one electron energy will be maximum, which is equal to 0. So he proved and he gave finally one equation. First let me write the equation. Total energy of free electron will be maximum, which is equal to 0. So this maximum value is equal to 0, and he gave one equation from the equation and he proved that, so when you take free energy of free electron, when you take 0, then only you can get values when electron in the orbits. This is what he proved. Now let me write equation according to Schrodinger. I think this equation is not given in NCERT. Okay, so don't think about this equation. How you proved so free electron energy will be equal to 0. Okay, don't think it. Why? Because this equation takes very lengthy and in your standards not required also. Okay, right. Now energy of electron means how you derived means, right. Now let us assume here this is what electron, our electron. So electron what he differentiated three-dimensionally. This is x-axis, y-axis and z-axis. So now electron is what moving wave nature as well as particle nature. Yes or no? So electron nature is what? Wave nature as well as particle nature. So now that's why it is a wave, means he consider wave like a wave model of electron, and three-dimensionally he differentiated equation and he proved that free electron energy will be equal to 0. That equation is, so dou square psi by dou x square plus dou square psi by dou y square plus dou square psi by dou y square plus 8 pi square m by h square, and here E minus V into psi equal to 0. So this is what the wave electron wave equation. Here this is what the free electron, and electron he differentiated along x-axis, y-axis and z-axis. He differentiated, this is x-axis and y-axis and z-axis. Right? If you take any body, definitely energy will be different with respect to what? Axis. Okay, with respect to axis also energy will be different. Actually we will think it, we are whatever you are calculating, just we are calculating with one dimension only. So three-dimensional energy will be different. So he differentiated three-dimensional energy of electron, then only you will get free. No, whenever electron in the free state, definitely it can go in towards y-axis or z-axis or y-axis, any axis it can has the motion. So due to that he differentiated along x-axis. This is what the derivation, dou square psi by dou x square. Dou square is the what? One operator. Okay, dou square is the what? One operator. Dou square psi. Psi, this name is what? Psi. Okay, this is what psi symbol. Here after you have to call it psi, and dou square psi by dou x square. So psi is the what? Wave function. So here what is the psi? Psi is what? Psi is equals to what? Wave function. Wave function. Wave function. This wave function with respect to what? This is what? With respect to propagating direction of electron, this wave function will be here plus and here minus, here plus, here minus, like that. This psi value will be plus or minus, you will get it. So plus or minus values you will get it. So whenever any body in the wave nature, definitely there will be a crest, there will be a trough. With respect to that, you will get plus and minus are the wave functions. Okay, so wave function. Now he with respect to plus and minus. Okay, so three-dimensionally he differentiated electron energy, then resultant he gave one equation, dou square psi by dou x square plus dou square psi by dou y square, this is along y-axis, plus dou square psi by dou y square plus 8 pi square m is the mass of electron by h square, h is the here Planck constant, into E minus V. So E is the what? Total energy, minus here potential energy, into psi. Here this is what the total energy, minus V is the potential energy. Okay, so this is total energy, and this is what? Potential energy. So potential energy, and then so here total energy minus potential energy, what will be the difference? Energy is equal to what? Potential energy plus kinetic energy. So any body has two kind of energies, potential energy and kinetic energy. Total energy of any object will be equal to what? Potential energy plus kinetic energy. Now here total energy minus potential energy means this value is equal to what? Kinetic energy only. Yes or no? Whenever electron in the free state, then what kind of it has, means it will be having what? Kinetic energy only. It is moving here and there. Okay, right. So here kinetic energy value, then which is equal to 0. For a free electron, this total energy along x-axis, y-axis, z-axis, then this equation is proving that this total whole thing will be equal to 0 for a free electron. So this is actually maximum. This value is maximum, but that maximum value, so he proved that when you take 0, then only you will get all values. Sorry, do z square. I told you z only, no? Yeah. This is y square and this is z square. Okay, right. So now, right. So first note down this equation. Copied, no? Right. This equation, what actually? This is what the equation given by the Schrodinger. And in our NCERT, we have what? H psi is equals to E psi, which is equals to 0. This is what we have. Okay, H psi, H is the what? Hamiltonian operator. This is what one kind of operator. So in mathematics there are many operators. Okay, so in mathematics there are many operators. Now this is what Hamiltonian operator. This is what operator Hamiltonian operator, and this is what the psi wave function. This is what the total energy. Then the psi will be equal to 0. So totally this is what we have in NCERT. H psi is equal to E psi, which is equal to 0. This meaning is what? Here total energy of electron, free electron will be 0. That's it. Whenever electron in free state, whenever electron in the free state means whenever it is means no attraction with the nucleus, then that electron energy will be maximum, that is equal to 0. That what in NCERT this is what we have equation, but actually this is what the one real equation. From this he proved that, and here you can make it. Now can I take it here? This is what whole thing is what I can take here, this whole thing. You can take whole thing is equal to what? This one, H cap, then psi. So H psi then is equal to what? E total psi into 0. Okay, this whole thing you can take it. This is what one kind of operator. Don't think much on this equation. Okay, if you think on this equation you will become mad. Okay, just we have this is what idea, what he was giving means energy of electron three dimensionally when it is in the free state it will be equal to 0. Okay, and when electron free means obviously being a small particle, so wave nature will be dominant. Then definitely once it is wave, then definitely there will be positive and negative. Positive is what? Wave function, positive wave function, and negative means negative wave function. This is a crust and this is trough. When it is in the crust it will be positive, when it is in the trough it will be negative direction of the electron. This indirectly what you can take here? Orbits. Yes or no? This is what? Orbit. So with respect to orbit, now here sometimes it will be crust, sometimes it will be trough. Right. Now what is the importance of psi? Here. Now this is what we are going to discuss. Importance of psi. What is importance of psi? Importance of psi and psi square. Now in this, which one is the more important? Right, here psi is the what? Wave function. So wave function means according to this what? If I take psi value is what? Here plus or minus we are taking. So what is the meaning of psi value? Plus and minus means what is the meaning of? Let us assume now this is what? Nucleus. Outside nucleus now you will be having the orbits. Let us assume now there will be electron. Now electron is moving in the orbits with wave nature, let us assume. Okay. Now here this is what? Now electron is what? Here. Or electron is here. Now what I will get here? If I calculate the position of electron from here to here, what I will get? Psi value. This is what the wave function. Psi value will be what here? Positive. Yes or no? If I calculate from the nucleus with respect to orbit, then electron position, what I will get here? Psi equals to negative you are getting. Right. Whenever you are finding the position, or whenever you are calculating the distance or finding positions never be negative. Yes or no? When we are finding position, where is your position means you have to say some positive distance. Yes or no? So having negative distance, is there any negative distance? Distance never be negative, no? Yes or no? You know at least up to this distance, whenever you are measuring distance, you have to say 10 km or 5 km or 1 km or 100 centimeter, something you have to give it. But sir, from my side means from this place to your place, what is the distance? Some meters. Okay, some meters you can say that. But distance never be negative. Whenever you are calculating, when electron in the trough part, this is the trough. When electron present in the trough, with respect to orbit, this is what the orbits, distance. With respect to orbit here, what you are getting here? Negative, no? Getting negative value is not valid. Okay, this is not valid. Not valid, but positive is valid. Right, now here if I take it psi, representation of electron, if I take it psi, then it is not possible. Why? Because here positive thing is what giving correct only, but negative thing, having negative wave function is a meaningless. Why? Because here we are finding the psi is the position of electron. Okay, psi is what here? Psi represents what? Position of electron in the atom. So whenever you are finding the position of electron with respect to psi, getting negative is what? Meaningless. Getting negative is meaningless. So finding position of electron, we are representing psi. This psi is what? Getting negative is meaningless. To avoid that, now if I take it psi square, then what will I get here? If I have the psi square, with psi square what I can take, psi square equals to what? Psi into psi, no? Yes or no? If psi square is what? If I have it positive value, then what will I get here? Positive into positive. What will I get? Positive only. Resultant what I am getting? Positive I am getting. Here if I take negative, negative into negative, what will I get? Positive, no? That means what? So psi square has importance or psi is has importance to find the position of electron in the atom. Which one has importance? Psi square is very, very important. Now here psi square is nothing but orbital. This psi square is nothing but orbital. So whatever you, where is the position of electron in the atom actually? Orbitals only, no? There are orbits in the orbital, suborbits like s orbital, p orbital, d orbital, f orbital. These orbitals are present. Now electron is present in the orbitals. So probability of finding an electron is that what? Psi square. Psi square another name is orbital. This orbital representation we are writing in the form of psi square. Okay, this psi square may be s orbital or p orbital or d orbital or f orbital. Yes or no? Later we will discuss. Till now we have only orbits. Later suborbits. Okay, in the suborbits there are orbitals. In a suborbit there is only one orbital. It is there in 9th standard and 10th standard you have, I think. In p suborbital means in p subshell there are how many orbitals? 3. px, py, pz. You have this information, no? Writing electronic configuration of any carbon, oxygen, nitrogen, argon. You don't have a 9th, 10th standard? You have, I think? No? You don't have atomic structure. Writing electronic configuration of atoms. When you know the atomic number. Okay, right, leave it. Right, so now we are discussing little deeply. Right, here what is a psi? Psi is what? Representation of electron. Hereafter you have to think it. Psi is what? In the atom. Right, now what I am taking here, psi, if I take psi, positive, having positive value, okay, meaning, okay, and negative value is what? Meaningless. Why? Because if I take psi, then it is not valid. Instead of psi, I will take psi square. Now to find the position of electron, then that is what psi square. If I take the psi square, whether it is negative electron here or here, anyhow psi square value will be positive only. Yes or no? So now psi square is what? Valid, and psi square is said to be orbital. Now define the orbital. What is orbital? What is orbital? How you will define the orbital? So write down definition of orbital. So orbital definition or psi square definition. What you can write here? Psi square. Psi square is equal to hereafter orbital. Orbital. So what is the orbital? How you will define the orbital? Electron density. Okay. Probability of finding electron density. Probability of finding electron density. Probability of finding electron density in the atom. In the atom is said to be orbital or psi square. That means what can I say here? Place of electron is said to be orbital in the atom. Yes or no? Place of electron in the atom is said to be orbital, no? Yes or no? Probability of finding electron. You are there in this room. Yes or no? Probability of finding electron. Now where is ShekharGowda sir? Yes, he will be in this what? Online classroom. That means probability of finding my place is what? This room only, no? Yes or no? Always I will be here only. 24 hours I will be here only. Finding electron means I will be here only. So right, my position will be what here? This room only. Same thing, probability of finding electron. Where probability of finding electron is more, that is said to be what we are calling orbital. Now where is the position of orbital? Means where is the position of electron? In the orbital. These orbitals are present in the atom. Yes or no? I am in the Gurukul campus. In that Gurukul campus, this is what the one room. In this room, my place. This is what my position. This Gurukul is what, like, let us assume atom. This room is like what? Orbital. Now my place is what? In orbital only. Yes or no? So probability of finding electron is said to be what? Orbital. This orbition will be psi square. These orbitals are different kinds. Like for example, psi square, if I write what? Psi square, 1s orbital, psi square, Okay, so 2s orbital psi square, okay, psi square, so 2p orbital psi square, 3d orbital, like that you can represent. Yes or no? So depends on what shell and orbital, you can write the representation. This is what the meaning is, what psi square, probability of finding electron, where electron is present in first orbit, s orbital. Okay, so now here 2s, where is the probability of electron here? In the second orbit, s orbital. In second orbit, s orbital, we have the electron. Next here 2p means in second orbit, p orbital. In that we have electron. Here third orbit, in the d orbital, we have electron. Single electron makes it to be orbital. Where is the orbital? In the atom only. In the atom, electron position is different. Protons and nucleons are inside the nucleus. Protons and neutrons will be inside, but electron is outside. Where is that outside? Where is the probability? It is not occupying complete. There will be some place. In that place only electrons will be occupied. That place name is what? Orbital. That place name is orbital. This is what spatially imagined. Means this man what imagine spatially there is a where probability of finding electron is maximum. That place is said to be what? Orbital. That orbital will be denoted by psi square. So hereafter psi square has importance but not psi. Okay. So finally what you can write? Note psi square has importance but not psi. That point also very very important. So note you can write it here. Note what you can write on note? Psi square has importance, not importance. So hereafter for orbital we will represent psi square only, not psi. Okay, representing psi is wrong. Means right what? For orbital means electron position with respect to electron position. With respect to electron position in atom. This is what the simplest conclusion of this Schrodinger wave equation. From the Schrodinger equation, main intention is what? Psi square has importance but not psi. Okay, this is what only you need to. What is a psi square? Probability of finding an electron. That what probability of finding an electron place is said to be orbital. Okay, now electrons are present in the orbitals. Orbitals are present in the atom. Are you getting or not? I am present in this room. This room is present in campus, Gurukul campus or building. Okay, like that. Okay, that is what the meaning. Right, this is what equation given by Schrodinger wave equation. Later we will use psi square. Psi square representation is very very important. Orbital. When there will be a bonding between the two atoms with electron, orbitals only will overlap. Means we will take psi function. So psi is the what? Representation. Psi square is the orbital representation. Okay, later in higher means other topics. In further whatever topic like chemical bonding topic, in that again we will use psi. Okay, right. So just keep it. Put in idea means what? Here you have to keep in mind psi square is nothing but orbital. Okay, right. Next right, quantum numbers. So what are quantum numbers? So quantum numbers are very very important to know the address of electron. Okay, to know the address of electron in the atom. Okay, it's very very important. Very simple. What are quantum numbers? So quantum numbers will address of electron. Okay, finally how they are giving address of electron in the atom we will discuss. Right, what is the importance of quantum number? To know the address of electron. To know the address of electron in atom. Address of electron in atom. This is what this is what main importance of quantum numbers. By knowing the quantum number, you need to means by knowing the quantum number, you can find the where electron is present in the atom. So electron to electron, place will be different, position will be different. Yes or no? In hydrogen we have one electron. In helium we have two electrons. First electron and second electron should differentiate, no? When they are differentiated means their address will be different in the atom. Yes or no? Otherwise, same address, same electrons. Then if they are same, then it's meaningless. In atom, every electron should differ with other electron. Even the one atom is having 10 electron. For all 10 electron, definitely you need to have at least one differentiator. One, at least some difference you should have it. All electrons are not same. Simply we are writing for example, neon configuration is there. Neon, what you are writing? 1s2, 2s2, 2p6 is the electronic configuration of neon. Atomic number is 10. Yes or no? Neon atomic number is 10. For 10 atomic number, what we are writing? 1s2, 2s2, 2p6. Now if I ask question, in 2p6 there are 6 electrons. All 6 electrons, they are similar or different? Yes, definitely they are different, not same. In s orbital, there are 2 electrons. Yes, these 2 electrons will be different. Okay, when we are differentiating, you are same or different? Though you are in the same campus, same room, definitely you are different. Yes or no? So the same way, even though electrons are present in the same atom, in the same shell, same orbital, definitely they are different. What is the difference? That what only we are going to discuss. So by knowing the quantum numbers, you will get what? Address of electron, where electron is present. So that what by representing quantum numbers, you will get the address of electron. Right? In this quantum number, there are 4 quantum numbers. By knowing the 4 quantum numbers, you will get the address of electron. Right? There are 4 quantum numbers. In this what? There are 4 quantum numbers. Right? Quantum numbers are, there are 4 quantum numbers. What are those? First one is what? Principal quantum number. Principal quantum number. Second one is azimuthal quantum number. Azimuthal quantum number. Second one is, third one is magnetic quantum number. Magnetic quantum number. Fourth one is spin quantum number. Spin quantum number. So principal quantum number represented by here L, and azimuthal quantum number represented by L. Magnetic quantum number represented by M, L. Spin quantum number represented by S. Okay, this is what the representation of quantum numbers. Quantum numbers. So principal quantum number, azimuthal quantum number, or orbital quantum number. You can call it this is what? Orbital. Or another name is what? Orbital quantum number. So orbital is okay. Later we'll discuss. Okay, right. Just first you write down. There are 4 quantum numbers. By using these 4 quantum numbers, you can find the address of electron in the atom. Okay. So these 4 quantum numbers are different from electron to electron. No two electrons have 4 same quantum numbers. At least they should differ with 1 quantum number. Yes or no? At least they should differ with 1 quantum number. Then only you can say every electron will be different. Yes or no? At least they should differ with 1 quantum number. That what? Which quantum number means? At least spin quantum number. Write down that point first. You write down here below. In the atom, in the atom, no two electrons have same quantum numbers. No two electrons have same quantum numbers. At least they will differ with spin quantum number. At least they will differ with spin quantum number. So in starting I gave no. Okay. No two electrons have same quantum numbers. At least they will differ with spin quantum number. Okay, right. That means what? Every electron will be different. They are not same. Okay, right. Now how they are same? Once you complete the quantum number, you will realize. Okay, I will explain how they are differentiating. Okay, even though they are in the same atom, you have to differentiate. You have to recognize. No. Okay, this is Cauchy, this is some X, this is what Y, this is what Pu, this is what Q, something like. Okay, we have to distinguish. Okay, right, like that same way electrons also we have to definitely we will distinguish. Right, now first one is what? Principal quantum number. Put side heading principal quantum number. Principal quantum number represented by N. Right, who proposed this principal quantum number? Tell me where we used this N value, N representation. Where we used N? Huh? N, N, small n, where we use this n. This is what? Principal quantum number. Already I gave once when I taught in the Bohr postulates. Yes or no? Orbit number, shell number, another name is principal quantum number. Yes or no? Orbit number, shell number or principal quantum number, all are same. They are represented with En. Now tell me, who proposed this principal quantum number concept? Who proposed this principal quantum number? Niels Bohr, Bohr scientist. Yes or no? Right. Principal quantum number, or this is what? Shell number. Shell number or orbit number, or BIT, orbit number. This is what? All are same only. This was proposed by Niels Bohr scientist. Okay. Bohr, Niels Bohr scientist. Who proposed the principal quantum number means Niels Bohr. So right, according to Niels Bohr, in every atom there are how many number of shells? Right, this is what in the outside nuclei there are what? Circular orbits. There are circular orbits. In these circular orbits, so electrons are what? Present. Yes or no? Right, this what? First one, n equals to what? 1, 2, n equals to what? 3, like that n equals to 4. So now you will be having here n equals to 1, 2, 3, 4, 5, 6, 7, 8, and here you can write K, L, M, N, O, P, Q, R, okay, like this, up to infinite, okay, but maximum we have 7 only, okay, this is what the representation, okay. So principal quantum is nothing but shell number. In every atom there are what? Infinite number of orbits are present, or principal quantum numbers are present, yes or no? This quantum number, first one name is what? 1, second one 2, 3, 4, like that, or K, L, M, N. You can use this one also. This is what K, this is what L, this is what M, after that N, like that. 1 or 2, 1, 2, 3, 4, or K, L, M, N, O, P also you can represent. Okay, right, this is what he proposed. Right, by knowing the principal quantum number, what are the properties I know that regarding electron? For example, 1s electron is there, 2s electron is there. Then what is the difference here? What is the difference? 1s, 2s. Yes, electron will be present in the first orbit. 2s means second, means electron will be present in the second orbit. Yes or no? By knowing the principal quantum number, indirectly you are getting what? Size of the electron you are getting from nucleus where electron is present. Yes or no? Principal quantum number is more. Then what about size of atom? More. And what about energy? Energy also more. Yes or no? Yes or no? Energy also will be more. That what means principal quantum number is what? Giving details about what? Size of the atom and energy of, means size of the electron means size of the atom means with respect to orbit number, and energy. Energy also we are getting. Right, from the principal quantum number you will get what? Energy information and as well as radius information. Radius information. That point you write down. Already I gave energy formula, and what you can write down? What is the energy formula? Right. So now here you can write it down. Principal quantum number. So principal quantum number is directly proportional to this fellow n. Is directly proportional to radius of orbit, nth orbits, and directly proportional to energy of electron. When electron present in the first orbit, second orbit, third orbit, definitely they are differ with energy, and with respect to size also that atom will be different size. Okay, orbit number increases, size will increases. Principal quantum number increases, size will increases. Orbit number or shell number, principal quantum number, all are same. Right, now already I gave what formula? What is the formula for radius? Radius means Rn for nth orbit. N is the principal quantum number. So Rn is equal to what? 0.529 into n square by z. This is what? In angstroms. Yes or no? Right, which is equals to what? Which equals to 52.9 into n square by z in picometers. Right. So actually here we don't have derivations in NCERT, but if radius value radius value for the electron, then this value will be equal to, let me give the values. Right, this radius of nth shell, this value will be equals to, this is what Rn, we are calculating Rn, n square is, here you can write h square upon 4 pi square me square z, here k, and into n square by z. If you put it all values, here what is the, h is the Planck constant and 4 pi is the constant value, 4 pi value 22/7, and m is the what, mass of electron, and E is the what, right, charge of electron, and k is the what, constant. If you put all values, then you will get value in angstrom, you will get this much value. In picometer you will get this much value. N is the orbit number and Z is the atomic number. This is what actually we don't have derivation in the NCERT. Okay, but if you want to calculate, means if you derive, you will get equation like this. This is what here n square by z, no? Yes or no? N square by z. This is what, n square by z. This value will be equal to this much. Okay. Radius of orbit. So you can write it here. So radius of, this is what, radius of orbits, nth orbit. Radius of nth orbit or n principal quantum number. This is what the formula. Okay. Right, next, energy. Energy of nth orbit. Energy of nth orbit, that is what, En. En which equals to what, in electron volts, minus 13.6 into what, Z square by n square. This is what in electron volts. And in joules, minus 2.18 into 10 power minus 18 into Z square by n square. This is what, joules per atom. Per atom we are calculating. Per mole means you need to multiply with Avogadro number. Right. If you take derivation, En which equals to, right, if you derive the value, energy value, so you have the derivations in physics. Okay, in physics you have derivations but not in chemistry. Right, so energy for electron, 2 pi square, here minus 2 pi square m e power 4 by Z square into, here Z square by n square. Now if I put this, what I'll get here? Here 2 pi. This is what constant. This is what the conversion. 1 electron volt will be equal to 1.6 into 10 power minus 19 joules. This is what the conversion of energy. Okay, then you'll get what? That value only you'll get it. You can do the criss-cross also. Here 2.18, okay, 1 electron volt equals to 1.6 into 10 power minus 19 joules. Then 13.6 electron volt equal to question mark. If you put it, you have to get this value. Yes or no? Yes or no? 1 electron volt equal to 1.6 into 10 power minus 19 joules. 13.6 electron volt equal to how many joules? Then answer you have to get this, no? You have to get it. Then only it is correct. That relation is correct. Yes or no? Definitely you will get it. You can check this. Okay. Right. This is what formula for. Means here what is the difference here? N value is there. Orbit number. Yes or no? So energy and orbit number. Orbit number is what? Here principal quantum number. So from knowing what n value is different, then energy will be different. And here what n value is different and radius of orbit will be different. Yes or no? Now sizes and energies are depends on what? Principal quantum number. This is what information we got from the Bohr only. So, and this is a principal quantum number also proposed by the Bohr scientist. And one more, if you want, here let me give it just continuation energy. Here total energy will be equals to what? Potential energy plus kinetic energy. Now let me give it in JEE advanced point of view. Once offline starts, we will teach very deeply. So now we are doing up to NCERT levels, we are not expanding NCERT. Right, continuation of energy and total energy of electron in the nth orbit will be equals to what? E kinetic energy plus E potential energy. This is what you have to get it. So total energy of electron in the nth orbits, is it negative or positive? Total energy of electron in the orbit, is it negative or positive? Negative only, no? In the formula negative sign is there everywhere. Yes or no? Total energy of electron in the orbit, nth orbits, okay? Right, electron energy in nth orbits. In nth orbit, if it is free, it will be 0. It will be free. Free means 0 you will get. When electron in the nth orbit, any orbits, then it will be negative only you will get it. Now if you see the relation between ratio, so E total, E kinetic energy and E potential energy, if I take the ratio, then here it will be, ratio will be what? 1 and 1 and 2. And if you talk about ratio with in terms of negative, and it will be negative. This is what the ratio will get. Here what potential energy is always 2 times of kinetic energy. Yes or no? What is the meaning of this one? Potential energy is what? 2 times of kinetic energy with negative. Now if I do it what? Adding -2 and +1, what I will get resultant? -1. Total energy is what? -1 only, no? Yes or no? This is what energy relation, please keep in mind. So kinetic energy and potential energy ratio is what? Like this. Okay. This is what one simplest once they ask in JEE. Right. So in physics point of view, you will derive total energy and kinetic energy and potential energy ratio will be 1:1:2. But here total energy and kinetic energy formula is same, but with the opposite sign. Okay. If you multiply with 2, then with the total energy, if you multiply with 2, you will get potential energy. Potential energy sign and kinetic energy sign exactly opposite. Total energy sign and potential energy signs are same. -2 + 1, resultant -1. So total energy is also minus. That's it. Simplest relation we are. This was the simplest ratio. This ratio, whatever energy you take it, always you have to follow. You have to get this ratio energy of electron in the nth orbit with respect to total potential energy, kinetic energy. Okay, right. This is what energy relation. Next, one more point. Let me give it velocity of electron. This velocity also you can say with the principal quantum number, velocity of electron in nth orbits. In nth orbits. So both successfully calculate velocity. It is not mentioned in NCERT, but here Vn, which is equals to 2.18 into 10 power 8 n by z. What is the electron here? How will be the electron? Z square by L square, no? Alright. Here Z by L. This is what speed of electron. This is what in meters per second. Meters per second. Right here, velocity of that what electron velocity. When electron is moving in first orbit, second orbit, third orbit, fourth orbit, in any nth orbits. Okay, then this is what formula directly you can use it. Now tell me here, what is the relation between principal quantum number and speed of electron? Inversely proportional. That means what here? This is the nucleus, first orbit, second orbit. Now electron is there in the first orbit, n equals to 1, and now electron in the second orbit, n equals to 2. Now tell me, where electron speed will be more? First orbit. So whenever electron very close to the nucleus, then attraction will be more. To avoid means if attraction is more, then to avoid this electrostatic attraction, then speed of electrons will be maximum. So it will be more compared to orbit number. When electron far from the nucleus, then its speed decreases. Okay, whenever it is very close to nucleus, so it has to maintain high speed. Then only it cannot attract it with positive. Otherwise, electron will collapse. Yes or no? So when we are moving, means any body is moving around a center part. So center and that body have the attractions. To avoid the attraction, you need to maintain some speed. That speed will be what here? 2.18 into 10 power 8. With respect to orbit, it changes. In the first orbit, what will get for hydrogen? So 2.18 into 10 power 8 meter per second I will get it. Here Z value is for hydrogen 1 and N value is 1. What I will get here? In kilometers, what I will get here? Tell me. In kilometers we have to calculate. Electron speed in the first orbit. What speed you will get? So 2.18 meter. This is what meters. Meters 1 meter, 1 kilometer equals to how many meters? 1000. 1000 means what will get here? 10 power 5. 5 yes hello. 10 power 5 kilometers per second. Yes or no? So 10 power 5 means what? After 2.18, if you put it to 5 zeros, then 5 zeros means what will get value? 2 lakhs or 20 lakhs? What will get? 10 power 5 means what? What is the value? Ones, tens. Now 21. This value is equals to this sum. We have to put it what 2 or there and 3. This is what the value of? Yes or no? In kilometers. Hundreds, thousands, 10,000 and lakh. 2,18,000 kilometer per second. In 1 second, electron is moving what? 2,18,000 kilometers. 2,18,000 kilometers it is revolving with that speed. Alright, to reach here to attraction, whenever electron is very close to the nucleus, definitely it has to maintain the high speed. Then only electron will be stable in this orbit. Otherwise, if it is slow is there, means if that what is slow down, then definitely it will attract with the nucleus. Then atom will collapse. Atom will collapse. Right. One thing here in physics also, you are that what if you that was stable in the orbit. Otherwise, it will not. Okay. This is what proved by the Niels Bohr. Okay. Right. This is what related to principal quantum number. Then finally, what you can conclude? Principal quantum number says radius of the orbits. When principal quantum number is more, radius of orbit will be more, and principal quantum number is more, then so energy also will be more. Here negative, then n value will be directly proportional to energy. Next, principal quantum number is more, then speed of electron will be less. Speed of electron will be less. So these are the points, 3 main points that what you can get it from the principal quantum number. Out of 4 quantum numbers today, we have discussed only first quantum number, principal quantum number. Tomorrow, remaining 3 quantum numbers we will complete. Once you complete, then what will get information? You will get the address of electron, where electron is present in atom. Then we will get address. Okay. Right. Tomorrow I will continue. Thank you. Okay.